Hi, my name is Connie Lawhead. I'm the president of DeShalm Technologies, LLC. The founders of DeShalm Technologies combined have over 60 years of experience in the HVAC market. Now, with 60 plus years of experience, we have seen or experienced many challenges with HVAC equipment. A perfect example is an issue that has plagued the industry for many, many years, and that's the standard P-trap. Now, we have taken an idea, we've developed it, we've patented it, and building it in-house to solve this very issue. We have two traps. One is a positive pressure waterless trap, the P-series, and the other is a negative pressure waterless trap, the N-series. Now you may ask, why are your traps better than the standard P-trap? There are many advantages to our traps, which in the following video we will go into greater detail about the functionality, the advantages, and ultimately the installation process. But let me highlight a couple I think are important. The first being that since our trap operates dry, there's no standing water, so freezing traps goes away. Another important advantage to highlight is the reduction of sludge buildup that you see in a standard P-trap. The third advantage I would like to highlight is the reduction in space required. Now, the standard building code for a standard P-trap states that from the drain connection down to the first 90-degree bend should be double the plenum pressure. In many cases, mechanical contractors have to install roof curbs, or I have even been told drill through roofs in order to get the proper installation. We state that approximately 50% reduction in the required space to install our traps. And it's very simple. Our traps do not require double the pressure in order to function properly. Now, when you review the following video, you're going to see a lot more detail on all of the advantages. But after reviewing the video, if you have any questions, please do not hesitate to go to our website, which is www.deshalmtechnologies.com, or send an email to info@deshalmtechnologies.com. Thank you.
Today I'm going to be demonstrating the positive pressure trap. It's a dry trap by DeShalm Technologies. The reason we have a positive pressure trap other than the standard P-trap is that a positive pressure trap will operate properly dry. No air passes through the system, drain system, when there's no water being condensed or after a long period of time when a normal P-trap would have dried out. The second advantage is that since it operates dry with no condensate, it has much less chance of ever freezing. It depends upon the installation and where it is. The third advantage is that because it operates dry with no airflow, it could operate better when condensate does flow in a P-trap. A lot of times the trap never fills up because the pressure in the unit causing air to flow out of the unit rapidly if it's dry to begin with causes the water to be carried with the airflow, and it never fills up with water. So air is always passing out. Air-conditioned air is leaving the building. The fourth reason that it could be an advantage over a P-trap is that it's operating vertically, and when there's no condensate, it's going to be dry. So there's much less chance of any crud building up like it would build up at the bottom of a P-trap. Okay, now let me explain the setup. I have the positive pressure coming into the top, and it's adjusted to 2.5 inches positive pressure. and the water flow is set at 1.6 gallons per minute, which, by the way, 1.6 gallons per minute of condensate is equivalent to 67 tons of latent cooling. So it's very representative of a maximum amount you would have coming off, but it'll carry more than that. Okay, the water comes in at that vertical tube over there. The water comes in at the second connection down, goes down the tube and out to the drain, to the trap rather. Now I'm going to walk over here and show you a little bit of close-up. Water is not flowing now. I'm going to start it up in just a minute, but there's the drain trap with the cylinder inside. It's a cylindrical float. When the water starts flowing, it lifts off the seat, which is at the bottom. The seat, the valve is between the cylinder and the seat. Now, normally, if you use 1 1/4 inch drain pipe, and it's not a extremely long distance from the unit on the roof to the drain wherever it is you're draining it to, the system just works fine. However, if you decide you're going to have to use 3/4 inch drain pipe or something along those lines, what happens is the water leaving the trap goes out through a small drain pipe over a long distance, and it could actually fill that tube. And as it flows, it creates a siphoning effect at the bottom of the trap, and that would cause a negative pressure on the bottom of the trap added to the positive pressure on the top of the trap would prevent the ball from the cylinder float from ever leaving the seat. So if you insist on using a small diameter pipe, which this is not, it's 1 1/4, which is going to be satisfactory. But if you use a 3/4 inch, then you need a vent pipe like is shown to the right of the trap. What that does is it prevents a suction pressure on the bottom of the unit, and the system works just fine. If you don't have that vent pipe, the cylinder bobs up and down as it's building up and relieving suction pressure. Okay, all right, I think enough said now. I'm going to start it up, and the reason I didn't have it running before, this vacuum cleaner makes a lot of noise, so I'm going to go over now. First, turn the water on. Yeah, you can see the water now flowing in the trap. Ball is up off the seat. And like I said, it's 1.6 gallons per minute. Now I'm going to plug in the vacuum cleaner. Just bear with me. What you see here now is 2.5 inches of positive pressure. I'm going to go over here now. We're going to take a look at the ball. Okay. You can see the water flowing past the ball, cylinder rather. That's 1.6 gallons per minute. The cylinder is up off the seat. Okay. Now I'm going to turn it off, the water off. And now the cylinder has gone down against the seat, and no water is flowing. Now, you see water dripping at the top. There will be probably a little pop-up off the seat to let that water out. You can see it going down right now. See, there's water's... Okay. That's it.